Okay, first of all, I would like to thank you for joining this web presentation of CivilFEM, the strongest name civil engineering solution. Okay, let's start by talking about the company. CAE Solutions LLC is an India cyber partner and distributors in USA and Latin America for CivilFEM software. Okay, we offer specialized solutions in computer-aided engineering software according to the needs of our customers. CAE Solutions is registered in Florida, USA. Okay, there we have our offices. We have a great team composed of experts in civil engineering solutions with more than 30 years of experience in professional practice in civil engineering problems and practice. Our core values, those are that we give to our clients, it's quality, integrity, respect, discipline, loyalty, honesty, collaboration. Let's see what is CivilFEM. Okay, making a summary of all that you see here in the slide. CivilFEM is a civil engineering purpose finite element analysis program capable of solving a wide variety of problems, okay, such as high nonlinearities, together with transient analysis and evolutionary construction process, among others. Okay, let's talk about some features of CivilFEM. We have a very user-friendly and easy to learn software. It's very easy to learn, it's very friendly. Okay, CivilFEM is configurable, including you can import, export geometry, and you have the ability for the user to enter data using parametrics formula. You can develop scripts and macros with Python language. That means that you can use the software, you can make your routines according with the requirements or the needs of the client. Okay, we have object-oriented architecture, automatic analysis and report. It's a very easy to use software. Let's talk about a little bit of our international clients. Here in this slide, you can see that there are a lot of important companies, such as Atkins, ISQ, among others. This information can show that the kind of software that we're presenting here in this web presentation. Okay? Okay, let's talk about now a little bit more of CivilFEM software. Okay, CivilFEM is a multiple integrated software because it works simultaneously with a powerful solver with the Mark technology. Okay, at the same time you can perform Python scripts, as I told before. You can develop macros. You can have your own parameters, and all this information is parallel, is simultaneously. Okay. Also, you can have advanced civil engineering applications such as bridges, dams, seismic applications, pre-stressed concrete, reinforced concrete, tunnels, geotechnicals. You have the software and multi-language and flexible units. Okay, another important thing is that we can perform nuclear power plants design, and you have all of these characteristics together in one powerful software. Okay, that is CivilFEM. If we talk a little bit of CivilFEM capabilities, in the structural analysis, we can perform linear and nonlinear, static and dynamic analysis. We can perform nearly linear and nonlinear buckling analysis, model and spectrum analysis, harmonic analysis. We can evaluate time-dependent variables like creep, shrinkage, among others. We can evaluate or we can perform advanced material behavior. We can perform staged construction. We can evaluate cracking and crack propagation, heat transfer analysis, and seepage analysis, among others. Okay. We can handle and we support a lot of material behaviors, such as isotropic materials, orthotropic materials, and isotropic materials. We support different plasticity models, talking about time-dependent behavior like shrinkage, creep. We support the viscoelasticity behavior, viscoplasticity behavior. We have temperature-dependent properties when we are talking about heat transfer analysis. We can manage user crack data on the crack propagation. We can perform nonlinear reinforced concrete analysis. We also have a specific soil and rock behavior, such as elastic model, the Drucker-Prager model, Moore column, among others. In the concrete design, we support a lot of codes, as you can see in the slide, such as ACI in the United States, Eurocode, okay, the CEB FIP model, okay, the Russian code, Brazilian code, among others. And other capabilities in the concrete design, we can make interaction diagrams in 3D, axial and moment in two planes, axial and moment checking in two planes, shear and torsion checking, shear and torsion design, plates and shell reinforced. We also support a lot of steel design codes, such as Eurocode 3, AISC, both of AST and LRFT models, bridge design specification, the British standards, Indian standards, and among others. Okay, CivilFEM is discretized in several products, okay, such as FEM Intro, FEM Advanced, Expert, add-on mark, nuclear power plants, and the student versions. Okay, let's start talking about a little bit, showing a little bit FEM Intro. Okay, basically, FEM Intro is the software that works on structural civil engineering and structural problems, such as earthquake analysis, among others, with basic nonlinearities and dynamics. Okay? The specific civil engineering and structural analysis outputs, such as load path history, automatic response spectrums for seismic analysis, and nonlinear time history analysis are fully supported here in CivilFEM Intro. Okay, we have a highly accurate solutions because all materials properties are time dependent and allow the definition of true stress strain diagrams and advanced non-linear behavior. Basically, in CivilFEM Intro, we have linear structural simulation with some nonlinearities, as I told before. In these terms, we can perform static and transient analysis, nonlinear transient analysis, modal and spectral seismic analysis. We can check all design requirements according to steel and concrete codes. Okay, we can evaluate large deflections and large strains. We can evaluate contact with frictions using the springs, dampers, among others. Okay, we can import or export from different applications or different formats such as DX, F, Parasolid, among others. We can have scripts and macros made to our needs with Python. We can make automatic reports, among other things. In CivilFEM Intro, you can see here in this slide several applications. Okay, for example, in bridges, okay, where you can check the deformation and the stresses of the structure. We have also industrial applications. We have also steel static and nonlinear analysis for transmission towers. Okay, we have seismic analysis tools. Okay, user spectrum definition independently from the code. You can enter and make your spectrum no matter what code you're using. Automatic mode combination according to the code specifications when you're making spectral response spectrum analysis. For example, in this slide you can see the model of the Tacoma Bridge study case. Okay, it was modeled in order for us to evaluate and compare the behavior that bridge took on that time. Okay, let's talk a little bit CivilFEM Advanced. As you can see here, CivilFEM Advanced has the same capabilities of CivilFEM Intro plus nonlinear buckling, nonlinear evaluative construction process, nonlinear strain stress diagram, okay, taking into account plasticity and user crack data, nonlinear reinforced concrete analysis, concrete time dependent properties such as creep and shrinkage, okay, the material model exponential cap, user crack data, press stressed reinforced concrete, bridge tools, tunnels, retaining walls analysis, pipes and micropipes analysis, among others. For example, you have here advanced applications of the CivilFEM in bridges and wind turbines. Okay, in the foundation design. Okay, we have a great characteristic here in the CivilFEM Advanced in the design or the evaluation of the excavation tunnels in 3D. Here you can see all the behaviors and evaluate uh, the main characteristics in stress, strains, and the complete behavior of the tunnel that we are performing here. For example, you can also have in the tunnel applications staged constructions. Here you can see in function of the time how and the construction process, how stresses and the results are variable in the time. As I told you before, you can evaluate and perform retaining walls behavior, taking into account all interactions between the soil and the structure of the retaining wall. We can perform non-linear time history analysis to a 3D dam, for example. Okay, in Civil Expert, as I said before, it has the Civil FEM Advanced characteristics or capabilities, plus the crack propagation, the conversion of solid to a shell model, laminated material, heat transfer, and CPH analysis. For example, in CivilFEM Expert, you can make construction phases. Okay, for example, in this image, you can see the construction phases of a dam. Okay, and in which we could evaluate the thermal nonlinear behavior when we are making this process of construction phases, and how it affects the final situation, the final structural behavior of the structure. Okay, in nuclear power plants, okay, we have the capability and the validation, and checking of the built-in nuclear codes, such as ACI, ANSI, ASD, and LRFT, among other codes. Okay, we also have the feature of the conversion of the solid to shell element. This is the capability for obtaining a virtual shell model from a solid 3D one. This is included in Expert and NMP. Okay, in the Postprocessor, which is the plot of results, we have three different information that we handle. We have the nodal results in terms of displacements and rotations, reactions, fixed boundary conditions, release, and all of those stuffs. We have end results. These results are derived data as generalized stresses and strains, force and moments, axial bending, shear, and twist. We also can evaluate the curvature for each of the elements that we are studying. And we have element results. Okay, we display the solution results as a continuous contour across the element boundaries. Okay, we have the stress and strain components, such as elastic and plastic, equivalent stresses and strains, among other things. Okay, I'll show you an image of the Postprocessor, where you can see how the stresses and the strains, deformations are evaluated in contours along the element. We have automatic report generation, which allows us to make a report at a glance of a click. Okay, now I would like to present you a little video of an example. This is a cantilever beam, okay, subjected to a point load, and in terms of the time, we can see how is the crack propagation. Okay, I'm gonna stop here. In our consulting services, okay, our international practice in the field of civil engineering allows us to provide the latest technology in structural engineering consulting services. Okay, we are always performing research in finite element FEMs, and join with institutes of technology and structural engineering universities. So we are proud to offer to our clients our consulting services in terms of structural design and in the whole civil engineering term. Well, this has been all, and for finishing, I would like to say thank you, and well, I will see you in the next time. Thank you very much.